Okay, welcome to a review of Chapter 10, the work we did with statistics or data. Um, we'll get started with some definitions. How do you find the mean, median, mode, and range? And by the way, these three first terms, mean, median, and mode, we call measures of central tendency. The mean is going to be the sum of all the values divided by how many values there are. The median is the middle value of the data set. And we find that by arranging the data set in order and then just crossing out the outsides till we get to the middle. The mode, most common number in the data set. Then the range isn't a measure of center, but it's an important thing to find. You'd find the maximum and subtract the minimum, and that's the range of values. To talk about max and min, we can look at something called the 5-number summary. The 5 numbers include the minimum and the maximum, smallest and largest values. From there, typically when we're doing the 5-number sum, we find the middle, median, which was already discussed, and then quartiles. If you split the data into 4 equal pieces, the range of the data in between those might be different, but there'll be the same amount in each grouping, all 4 groups. And so the first fourth is the middle of the lower half of the data, and the last fourth is the middle of the upper half of the data. And you could think of the median as quartile 2 if you wanted. All right, if asked to find the 5-number summary, which of the above values do you need? We would need the minimum, quartile 1, median, quartile 3, and the maximum. All right, now as we find the measures of central tendency, mean, median, and mode, we want to take our data set, have it in order from least to greatest, and to find the mean, we should refer to our definitions here. The mean is the sum of the values divided by how many there are. So when I add these up, I try to find patterns here. There's 10, then one that's 10, 4, 4, and 2 is 10, so I'm at 30, 40, 50, 60, 71, 84. So we have 84 total divided by 1, 2, 3, 14, and that looks like 6 times 10 is 60, another 24, so 6. All right. In fact, we'll go through and give you them all here. The median's the middle value, so if we were to cancel out from the outside in, 1, 2, 3, 4, 1, 2, 3, 4, 1. We end up with it's an even data set, so the middle 2 numbers would be averaged or added up and divided by 2. 5 plus 5 is 10, divided by 2 is obviously 5. So our median is going to be 5, and we'd put it right in between there. The mode is most frequently occurring. To identify that, we just count, and in this case, the 9 shows up 3 times, so the mode is 9. If we did have, let's say, fewer items, just 2 9s, we would have 1, 2, 3, 4 modes because they show up equally. If we only had one of each, there would be no mode, but when you have an equal number, more than one, all the values with the highest amount count as a mode, so you can have more than one mode. And then finally the range, fairly straightforward. We just take our greatest minus our least, 13 minus 1 is. Okay, to find some information from a fairly long data set, and I'll just give the answers. I'll talk about how we get them. It's worth doing the work. To find the 5-number summary, that would be the min, median, Q1 and Q3. You would find the median by counting out from the in from the outside. Find out in this even data set there are 2 values. Just find their average. This one's pretty obvious. If you want to find the min and the max, I think those are easiest to find first. Those you just, once it's in order, are fairly obvious. Q1's a little bit challenging, but really all we're going to do is, as the blue shows, put a line through the middle and then count in from the min and the median including the first value of our median. If the median is a single value, if we had an odd number in the data set, you would not include it. But since we have an even number, we're going to include the value to the left, this 22, as we try to find Q1, and then we include this 22 as we count to find the Q3. If we had an odd data set, we would simply exclude the median and just count to the left of it and to the right of it. All right, then to find the IQR, that'll be the interquartile range, the value between 19 to 25. So we do 25 minus 19, we get 6. And then to find some outliers to see if there are any, we would take the IQR, which in this case is 6, multiply by 1.5, that's 9. And then it gets a little bit tricky. We take the 9, add it to Q3, this is a Q3 here, we get 34. And we look to see, are there any values larger than 34? There are not. So then we take our Q1 and we try to see if there's any values below 1.5 times our IQR to the left. So we do 19 minus 9, we get 10, and sure enough there is one value less than 10, it's 8. And 8 would be what we call an outlier. It does not mean it's a bad piece of data, but it's one that you'd want to look into. All right. What is the value of the mean? Well, if you do all the calculations, I get 42 divided by the total number of values, which was 22, and I got 21.9. Okay, and then as we find the mode, we're looking for the most frequently occurring, and you can see up here 22 shows up 4 times. There's no other values that show up more. Even though some show up, like 19 shows up 3 times, it's not equal, so we would not say that 19 is a mode. It has to be the most frequently occurring, and then if there's any ties with how many, then we include all those values. But 22 shows up the most. There's no others. All right, and then last, let's make a box and whisker plot or box plot for the data set. If you do that, take your 5-number summary and plot the data on the number line. We see that the values 8 and 29 obviously show up. And then if we look down here, 25 and 19 are Q3 and Q1, and the median right there in the middle at 22. Without calculating which measure of center would change the most if an outlier is removed. In this case, we determined 8 to be an outlier. And just something you want to know, the mean will be most affected by outliers because it's most affected, in this case, by the value 8. When we find the mode, we cancel out the 8 like any other value that's smaller than the next value. But with the mean, we actually include it, and it gets added into the total values, and it always affects the mean. Outliers get excluded from modes quite easily because modes are most frequently occurring, and even the median. And now that we've covered the meanings of some of these values and how they do work when given a data set, we're going to do some interpretation problems on these next few slides. Might be a little bit challenging. You want to make sure you understand the meanings and how these values work together. So to start with, let's create a data set with 5 values where the median is 40, the mode is 45, and the mean is 30. In this case, we're going to have 5 spaces because we need 5 values. The middle value, or median, is 40. And then I need a mode to be 45. That means it has to show up more than once. And in this case, it has to be to the right of my median because it's value greater than 40. So what we're left with is trying to find these last 2. And there's going to be more than one correct answer, but I'll go through a quick way to determine it. We know that if we were writing the equation to find the mean, we'd have 2 values. They're undecided right now, plus the last 3, all divided by 5, would have to equal a total of 30. And we divide by 5. So let's work backwards. Let's undo divide by 5. We multiply, we get 150 equals x plus y plus, and the total there is 130. We'll subtract 130. Oops. And we get 20 equals x plus y. What we're saying here is you can pick any 2 values that are less than 40. In fact, they could be negative values, but we want them just not to repeat, because if they repeat, we'd have another mode, and we can't do that. So to choose fairly obvious ones, Let's go with 9 and 11. All right. Now working with another type of problem here, we have a data set that has all but one value, and we want this data set to have a median of 16. It's a little deceptive because they're not in order yet. So the first thing we want to do is put things in order, and then we're going to say this median of 16 has to come from the middle values, and in this case the middle values have to have an average of 16. So what we're saying is 14 plus what divided by 2 is 16. If you think about it for a little bit, it's got to be 18. So there is only one correct answer for this problem. All right, data set, data and box and whisker plot below shows the number of homework problems Miss Olson and Mr. Johnson assigned to their classes each night for the last 2 weeks. Miss Olson's box and whisker plot shows a smaller range, and Mr. Johnson shows a broader range. What do the box plots tell you about the number of homework problems assigned by Miss Olson and Mr. Johnson? What we can see here is that the medians are the same. In fact, they, on average, or in the middle, their middle amount of values they would assign is going to be right around 9. But Miss Olson is more consistent in her homework problems in terms of how many she assigns per assignment, where Mr. Johnson's box plot shows a spread. So he might assign all the way down to 0 problems for one assignment, but up to 20. Miss Olson assigns more consistently between 4 and 15, it looks like, roughly. For the data set shown in the histogram, how many cherry trees are represented? Well, the only way to find this is to actually count the height of the frequency for each in the interval from, let's say, 60 to 65, 65 to 70, and so on. And what we find is when you do that, you add those all up, you get 32. So there were 32 in this data sample. How many cherry trees are under 80 feet tall? Remember, if we included the 80, it would go to the right. So we're only going to work with the values up to 79 point whatever. If it's 80, it goes in the bin to the right. If you add those values, you get a total of 24. One quick question here too, what is the interval or bin width for each of these? And the answer there would be 5 feet. All right. And now a circle or pie chart. If 200 movies were categorized, how many were romance movies? If they went through and watched 200 movies and broke it out into percents like this, how many were romance? And the way we'd find that is we'd use the percent given, multiply by 200, the percent as a decimal, and we get a total of 60 movies that were romance out of the 200. Which two types of movies occur the same amount? And there we just look for the size and then make sure that they're percents. And if you look, you notice that sci-fi and comedy were roughly the same. They represented the same amount. Romance and action were more. Drama was far less. Which type of movies occur the least? And we just said drama. All right. For the following graphs, explain why graphs, they might be misleading. If you look at the one on the left here, this circle graph, they don't add up total to 100%, and that can be misleading. It makes all the values seem smaller. If you look at the graph on the right, you notice that the vertical scale doesn't start at 0, and this makes it look like, for instance, in 1999, ticket prices seem to be almost doubling in just 2 years. But there's quite a bit of the graph that hasn't been included if you go all the way down. And now we're going to look at some bias situations where the data might be accurate, but they haven't really tried to make it representative of an entire an objective sample. So you decide to find out how your neighbors feel about the neighbor who seems to be running a car repair shop on his front lawn. You place a questionnaire in every mailbox within sight of the offending home and ask the people to fill it out and return it to you. About half of the neighbors return the survey, and 95% of those who do say that they find the situation intolerable. Well, this is a little bit misleading because you used a voluntary sample and you only took information on those who had opinions. The people that responded probably were against the car repair shop. What you find is there's a quote that says, if you keep a customer happy, they might tell one person. If you make them upset, they'll tell 10 people. People, if you look online, people are more readily complaining about things rather than building others up. So in this case, you're kind of looking for some negative responses, and that's what you're going to end up with. You decide to conduct a poll as to how comfortable people are with technology. To conduct this, you send out an online survey to all email listed on a server. You discover that of the people who responded, 75% said they were very comfortable with technology. Why is this biased? Well, the medium you used is part of it. You used a voluntary sample, just like in the first example, but also the people that responded use internet, so they are comfortable. You aren't representing those who don't use the internet, or maybe those who are uncomfortable with the security. So, and then this last one, Malcolm surveys 200 members at a fitness club and calculates the median number of hours they exercise per week. Explain why this statement is misleading. The average person spends 10 hours per week exercising. Well, in this sample, we've only looked at people attending a fitness club. The assumption can be that those people exercise more than those who don't attend a fitness club. All right. Good luck on the test, and we'll see you in class.